Hi, myself Ganesh. Now I am going to explain NFA with epsilon transition and conversion of an epsilon NFA to DFA. Now you will see NFA with epsilon transition. Automata changing state by using epsilon transition means that the automata changes state from one state to another state by using epsilon transition. Here we are changing from state A to B by using epsilon transition. In normal NFA, we have by using an input symbol, we will change the states from one state to another state. But here we are changing state by using epsilon. Epsilon is not an input symbol. Remember this. Epsilon is not an input symbol. Now we will define epsilon NFA. We can define epsilon NFA by using 5 tuples. The 5 tuples are Q, sigma, delta, Q0, and F. Here Q is the set of states in automata. Sigma is the input symbol, input alphabets in the automata. Next Q0 is the starting state of the automata, and F is the final state of the automata, and delta is the transition function. Here the symbol represents that both the union of input alphabets and epsilon transition. This is the only change we are getting in epsilon NFA. Now we will see some example of epsilon NFA with epsilon and NFA. Here we have the transition of epsilon, so we can call this as NFA with epsilon. Here there is no epsilon transition, so this is normal NFA. Now we will see epsilon closure. Epsilon closure of state A is the set that contains A together with all states that can be reached starting at A by only epsilon transition. Now, after seeing one example, we have clarity on this. Means that here A is taken as a state. The set of epsilon closure is that A and the states that are reached by using epsilon transition from that A. In this example, see the all line states of the epsilon closures in here. Now, epsilon closure of A. Epsilon closure of A means first include that A here and then check the epsilon transition from that A. From that A we have an epsilon transition to D by using epsilon. So include D here. Next from D to E we have another epsilon transition. So include E. From E to there is no epsilon transition. So this is some set of states of epsilon closure. Now epsilon closure of B. Epsilon closure of B means include first B. From B there is no epsilon transition, so only B in this. No epsilon closure of C. Epsilon closure of C means include C. From C to B there is an epsilon transition, so include that B. From B to there is no epsilon transition, so C, gamma, B are the epsilon closure of C. Next epsilon closure of D. So epsilon closure of D means include D, and from D to E we have an epsilon transition, so include E. From next epsilon closure of E. Epsilon closure of E include E. There is no epsilon transition from E, so this all. These are the epsilon closures of the states. Next, see another example for more clarity. Epsilon closure of 0 in this state means include 0 here. Next, we can travel from 0 to 1 by using epsilon transition, so include 1. Next, from 1 to 3 there is an epsilon transition, so include 3. From 3 to 2 epsilon transition, so include 2 here. From 2 to there is no epsilon transition, so these are all the states for epsilon closure of 0. Next epsilon closure of 1, include 1 here. And from 1 to 3 we will move by using epsilon transition, so include 3. From 3 to 2 we will move by using epsilon, so include 2. From 2 to there is no states, so these are the states for epsilon closure of 1. Next for epsilon closure of 2, include 2. From 2 to there is no epsilon transition, so this is the only one state. Next epsilon closure of 3. Epsilon closure of 3 means include 3. Next from 3 to 2 we move by using epsilon transition, so include 2. From 2 to there is no epsilon transition, so these two are the states of epsilon closure of the 3, and these are the epsilon closures of the states. Next we will see conversion of an epsilon NFA to DFA. Let us use DFA BD and NFA BA. Let's take Q0 is the starting state of NFA. Initially, there is no states in DFA. We take epsilon closure of Q0 in NFA is the only state in the DFA. This is the main point. Here we can see that here. I will briefly explain about that. In epsilon NFA, the starting state of this is take a closure of that state. So the states that we have epsilon closure is the starting state in the DFA. So that is the point. And while there is an unmarked state T in in these states do begin mark T for each input symbol here to begin equal to epsilon closure of that unmarked state comma input alphabet. So by using unmarked states, we can travel using input alphabets and we can take that into D states. If there is no unmarked state, so we can end. By seeing the example, we have get a clarity on this. Like just see an example for epsilon to epsilon NFA to DFA. Take an automator with epsilon NFA. This is an epsilon NFA. Here we have epsilon transitions. So we can delete it as epsilon NFA. Now write the transition table for this epsilon NFA. So I will explain how to write transition table. Here just take all the input symbols and take all the states. Here Q0 is the starting state. From Q0 by using input symbol A, we are getting Q1. So include Q1. From Q0 to input symbol B, we are getting Q4. So here write Q4. From Q0 to C, there is no transition. So null set. From Q0 to Q1, we are moving by using epsilon. So write Q1. Next for Q1, by using A, there is no transition. So null. By using B, we are moving to Q1. So include Q1. From Q1 to Q2, we are moving by using C. So include Q2. Next, by using epsilon, is moving. There is no transition. So 5. Next for Q2. In Q2 to Q2, by using input symbol A, there is no states we are getting. So 5. By using input symbol B, we are getting Q3. So include Q3. By using C, there is no. And for epsilon also, there is no. So null. For Q3, there is no A. For B, we are getting Q3. For B, include. Next for 0 also, there is no. For C, there is no. For epsilon, we are getting Q5. So include Q5. Next for Q4. From Q4, we do not have A, B, epsilon transition. We have just A and C. So include just QC. From where we move Q3. So include Q3 and remaining all 5s. For Q5, there is no transitions. So all are 5s. Next, find the epsilon closures of all the states. Here all the states, just find the epsilon closure. Epsilon closure of Q0 means first include Q0 and from Q0 to Q1 here by using epsilon he is moving. So this is Q1. From Q1 to there is no epsilon transition. So just Q0 Q1. For Q1 include Q1. For Q1 there is no epsilon transition. So just Q1. For Q2 write Q2. For Q2 there is no epsilon transition. So just Q2. For Q3 write Q3. And for Q3 to Q5 we can move. So include Q5. For Q5 there is no epsilon transition. So just Q3 Q5. For Q4 there is no epsilon transition. So just Q4. For Q5 also there is no epsilon transition. So just Q5. Now we will write transition table for DFA. For DFA, first take the starting state of NFA and find the epsilon closure of that state. Means epsilon closure of that state is we already found Q0, Q1. So this is the starting state for DFA. Now here we can see that unmarked state. We can first find out the input symbols. and we have to start. So find the input symbols of the transitions for A, for B, for C. For A means we are getting Q0 comma A and Q1 comma A. For Q0 comma A, we can see here from Q0 by using A, we will move to Q1. So for Q0 comma A, Q1. For Q1 comma A, there is no, just 5. And for union of the Q1 and epsilon closure of Q1 is Q1 and Q0 comma Q1 for B we are checking. For Q0 comma B, Q4, so include Q4. Next for Q1 comma B, Q1, so include Q1. So we have Q1 comma Q4. These two states we are getting. Find the epsilon closure of that two, means Q1 epsilon closure and Q2 epsilon closure. Q1 epsilon closure is Q1 and Q4 is Q4. So Q1 comma Q4. Next check for Q0 comma Q1 using input symbol C. Epsilon transition of Q0 comma C. Q0 comma C epsilon transition means we are getting 5, so there is no. For Q1 comma C, we are getting Q2, so take Q2 and union of that Q2, epsilon closure of Q2. Epsilon closure of Q2 is Q2, so take Q2 and write Q2 here. Next, just see the unmarked states. Here, these three are unmarked states. So first include the first state and check input symbols for that first state. For first state, check inputs for A, B, C. For input A, Q1 to A. For Q1 to A, there is no, so just 5. For Q1 to B, we are getting Q1. So for Q1 to B, we are getting Q1. Epsilon closure of Q1 is not Q1. So epsilon closure of Q1 is, we can return Q1. Next, epsilon closure Q1 to C. We are getting Q2. So include Q2 and epsilon closure of Q2 is Q2. So include Q2 for C. So just write that all here and check the new states. Here we are getting Q1 also a new state. This is how previously we can get here. So next state is Q1 comma Q4. So write the input states for Q1 comma Q4 and we return the input states for Q1 comma Q4 here. Just check for Q1 comma A and Q4 comma A. There is no states, I think. Q1 comma A, there is no input symbol by using A, and for Q4 comma A, there is no. So this is 5 and there is no epsilon closure is also 5. For Q1 comma 4 also check like that. For Q1 comma B, we are getting Q1. Next for Q4 comma B, we are getting 5. So just Q1. So for Q1 is just Q1. Epsilon closure of Q1 is also Q1. Next check for C, Q1 comma C and Q4 comma C. For Q1 comma C, we are getting Q2. For Q4 comma C, we are getting Q2 and Q3. Just take Q2 and Q3 and epsilon closure of Q2 and Q3, we will get Q2, Q3 and Q5. And include that states here for that input symbol, and we are getting another extra state of Q2, Q3, Q5, and here already we have an extra state. So include that Q2 here and check again the input symbols of that here. We check that input symbols and again let's check for, and the input symbols we got is 5, 2, 3, 5 and 5. So just return that here and we get another extra state here. So we have an extra state, this and this. First write the input symbols for this. Okay, Q3, Q2, Q5. For Q2, Q3, Q5 for input symbol here, just check for Q2, Q3, Q5. Q2 there is no, and for Q3 no, for Q5 no. So this is 5, and for input symbol B, Q2, Q3, Q3, and there is 5 for Q3. Epsilon closure of Q3 is Q3, comma Q5. So we got Q3, comma Q5. Check for input symbol C. For input symbol C, we are getting 5, 5, 5. So this also there is no state, so just 5. Just write this in the table and just take the unmarked state Q3, Q5 and Q3, Q5 input symbols A, B, C transition is seen here. Q3, Q5A. For Q3, Q5, there is no transition for A, both are fine. So return 5. For B, Q3, Q5. For Q3, we are getting Q3 and for 5. For Q3, epsilon closure is Q3, Q5. So write Q3, Q5. For Q3, Q5, for input symbol C, we are getting 5. So epsilon closure of 5 is also A5. So include that. Just check there is no extra unmarked state. There is no extra unmarked state. So we can stop here. Now just convert the DFA epsilon transition table to epsilon DFA design. Here just include states all here like this and take an empty state also. Just I included all states and take an empty state, and now I will show how to draw the transitions for Q0 to Q1. Q0 Q1 from Q0 comma Q1 to we are moving Q1 by using A as a transition. So by using A transition, we move from Q0 comma Q1 to Q1. By using B transition, we move from Q1 comma Q4. By using C, we move from Q2. So just include that. From Q1 to A, we are moving. There is no we move to 5. So just include that 5. From Q1 to B, we are getting only Q1. So self state. From Q1 to C, we are moving to Q2. So Q1 to C, we are moving to Q2, and just include that all like this. And at end we get like DFA like this. So thank you. This is the full detail about NFA with epsilon and the conversion of epsilon NFA to DFA. This is the automata epsilon NFA, and we converted that epsilon NFA to this DFA design. So thank you.